So we are on the last day of Unit 1A. Meaning we have an assessment coming up this day. Wednesday. Yep. So next assessment is on Wednesday. We'll cover everything from last week. Systems of equations with 2 variables, systems of equations with 3 variables. And then what we're going to take care of today, where we're solving systems of equations by graphing. So when we're solving systems of equations by graphing, obviously we are going to take 2 different inequalities with 2 variables, and we're going to graph them. And we're going to look for a common region that they have shaded. So we may have one line that looks like this, where all of the possible solutions are everything that's above this line. So if I were to pick a point in this inequality, it would be a solution. We then are going to have a second line that's in there somewhere, and let's say that it's right here. And now yesterday when we were looking at this, or last week when we were looking at these, we were just looking at the point of intersection and said that was our solution. Well, when we're talking about systems of inequalities, we're talking about a region that's being shaded probably a couple different times. So let's say that all the solutions for that inequality are down there below it. We've then created this region right in here that has been shaded twice. And that region that's shaded twice then is going to be the region that contains the points that are going to be solutions to both of the inequalities. So that's the region we're trying to be able to locate today. Now, within this drawing, I've done a couple different things that we need to make sure that we take care of. First, you'll notice there's a dashed line. Okay. A dashed line is going to be made if you have an inequality that's greater than or less than. If you have an inequality in that manner, then it's going to be dashed or dashed, I guess. So, for example, if we had something like y is greater than x, or y is less than x, and that is by no means what I have drawn up there, but those are going to give you a dashed line. The other one you'll notice I made a solid line of, the one that goes in the negative direction. A solid line is going to be drawn if you have greater than or equal to or less than or equal to. So this would be something like y is greater than or equal to x, or y is less than or equal to x. That's kind of the first thing that you notice in there. And that's something that we always have to look for. The other thing you'll notice is where I shaded. I either shaded above the line or I shaded below the line. In the first case of the yellow, of the red one that's just greater than or whatever, you'll notice I shaded above it. And there's a rule for that, sort of. If y is greater than, then you are going to shade above. Above. If y is greater than, you're going to shade above the line. If y is less than, you are going to shade below the line. Now, it's very key that when we're talking about this, that it's in slope-intercept form. That you have it in the form y essentially equals mx plus b, where that's now your inequalities instead of an equal sign. This little thing here and here, that really only works if you're in that form. If you're in the form, standard form, ax plus by equals c, or is greater than c, that doesn't always work. So you want to make sure that if you're using this rule, that it's in slope-intercept form. All right, so those are kind of the things that we need to know. Is it a dashed line? Is it a solid line? Do we graph above it or do we graph? Okay, so let's say that we have this system of inequalities. We have y is less than 1/2 x minus 3, and y is greater than or equal to negative x plus 2. We're going to graph them independently. So we're going to take this first one and we're going to graph it just like it was an equation. So we're going to graph it just like it was y is equal to 1/2 x minus 3. Put it in slope-intercept form first. It's already there. We've got it in the form y equals mx plus b. The b is our y-intercept. Remember, that's the point 0, b. So in this case, that's the point 0, negative 3. So that's where we start. You put a point at 0, negative 3. You put a point there. Then from there, we're going to adjust by the slope. The slope of this case is 1/2. That means that we're rising up 1 and running over 2. Rising up 1, running over 2. And so on and so forth. So I've got my points to create that line. Now we look at the inequality. The inequality is less than. So first thing it tells us is that this is a dashed line. And it also says less than, so that means I shade below. So all of my solutions for this inequality are going to happen in this region. So what does that mean? It means if I pick this point, and that's the point 5, negative 6, that if I plugged that in, that it's going to make a true statement. If I plug it into my original inequality, that would be negative 6, I picked a bad number, is less than 1/2 of 5 minus 3. So that's negative 6 is less than negative 0.5. So it's a true statement. If I picked anything above that line, anything above that line is going to create a false statement. So for example, the easiest one to pick is 0, 0. If I plug that in there, anything times 0 is 0. So you'd have 0 is less than negative 3, and that's a false statement. So because it's a false statement, I'm not going to shade there. And I didn't shade there. I shaded below in the true region. So we've got the first one done. Now we jump to the second one. Well, here's our second one. Again, we're going to treat it just like it was an equation. My y-intercept is the point 0, 2. So I put a point at 0, 2. My slope is negative. So my slope is negative 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1. I only need 2 of them. It's easier to draw it straight. I look at my inequality. It's greater than or equal to. So that tells me that my line is going to be solid. And that I shade above the line. So I shade above the line because it's greater. Greater means above. So there's my shading above of that one. Now my solutions are going to be the region that has been shaded twice. So all of my solutions for both of these inequalities are the points within that shaded region. Okay? How's the graphing going? Looks like it's really well. Don't use that one. Yeah, that's it. Okay? That's graphing systems of inequalities. And you have to be careful when you do these. You got to take your time. Obviously, we're just going to end up sketching these for the most part anyway, but we can still do it. Okay, so let's look at the second one. We're going to graph the system where we have y is less than or equal to negative 1 and x minus y is less than 2. Again, we're going to graph this system. Start by graphing the first one. Treat it like it's an equation. Y equals 1. Remember, or negative 1. Remember, when y is negative 1, it doesn't matter what my x value is. My y value is always negative 1. Let's try to pay attention instead of messing around back there. My y value always has to be negative 1. So I got the point 0, negative 1, and 1, negative 1. My inequality is less than, so that means it's going to be solid. And I'm going to shade below. So there's the first one. Second one. We've got x minus y is equal to 2. And we're going to leave the inequality in there this time. It's not in slope-intercept form. So we're going to subtract x. So negative y is less than negative x plus 2. Now we have to divide by a negative. Remember, when you divide by negatives, inequalities, they flip. So y is greater than x minus 2. This is the one we're going to use now. So now we can write that as an equation. Our y-intercept is 0, negative 2. Our slope is 1. So that's up 1 over 1. It's a dashed line. And now this is kind of the important part. Make sure you use that one. So y is greater than. So it's going to be all the areas above the line. Your solutions then are the ones that have been shaded twice. Now, and again, it's important. You can see why it's important that you use this one and not this one. Because this says, if you just read this, it says y is less than. And no. Okay, it's not in slope-intercept form. Okay. Can you use this one? Yes, but you would use a test point. If I wanted to figure out if that was correct or not, I would just use the point 0, 0. 0 minus 0 is 0. 0 is less than 2. That's true, so that means I have to shade above it. Your region of answers are all right in there. So treat them like they're equations. Graph them like they're equations. Make sure you watch your inequality symbols. Less than or greater than, it's dashed. Less than or equal to or greater than or equal, it's solid. If it's in slope-intercept form, if y is greater, you shade above. If y is less than, you shade below. One more that I'll have you go through, and then we'll get off to your assignment. Have you do this one. Graph that system of inequalities, and then we'll call it good. Okay, so the first one, 2x plus y is greater than negative 3. I'll subtract 2x from both sides. Get a y-intercept of negative 3. Point at negative 3. Slope is -2 over 1. Dashed line is greater than it, so you shade above. Second one, subtract 2x from both sides, and you have to divide by -1 or multiply by -1. Make sure you flip the sign. Y-intercept is at +1, and then slope is 2, so up 2 over 1. Again, dashed line. It's less than it, so you shade below. Okay. Any questions? All right, take your time as you're doing these today. If you have questions as you go along, please make sure that you ask.